Cool. All right. Well, let's get on with it. So nice to meet you all. I'm Sebastian, I'm product manager here at Apebase. And once a month, I like to do these webinars to kind of just do the demo that we usually like to do when we are doing our discovery meetings, and just have it a little more interactive. All right. So feel free to ask any questions along the way. Pause me and dive deeper. But this will be a platform walkthrough and overview that really will kind of give you a good understanding of everything that we're doing, or everything that our platform allows you or enables you to do when it comes to application development. So I'm going to go ahead and do a screen share here. 1 second, I jump over. Cool, share. Right. Now I believe that my screen is being shared. And here we are in Apebase. Cool. So first off, important to say, what is Apebase? Apebase is a product, is a backend-as-a-service, meaning that we provide our customers with a ready-to-use backend solution, which is comprised of database, API, serverless layer, and then just some tangential services that you need to tie all that together and build a really robust backend to support your projects. Now that backend architecture that gets built is a 3-tier serverless architecture enabled on AWS. So API Gateway, AWS Lambda, Aurora MySQL, S3, OpenID identity providers, whole bundle in there. But really what it kind of abstracts away is the necessity to hire sophisticated backend engineers to build a stable, scalable backend. We've already done that. We have a pattern or a template that works for you that's configured to your project domain, and that becomes the backbone of your application, really. And we have a lot of really great customers that show that that is a working model, which we're excited about. So what I'm going to do is, here we have this concept of workspaces. A workspace can be thought of as a project, its own database, its own API, its own project necessarily. And right here from my developer home, you can see that I have a list of different projects here that I participate in, have built for myself, collaborate on, so on and so forth. So I'm just gonna go ahead and jump into one that's already built that we can kind of start to walk through, called MRP Backend. However, creating one of these workspaces, extremely simple. Click Create Backend, give it a name, select the region that you want the infrastructure hosted in, select a plan. So everything from the free tier to $150 a month, and then we do custom plans for different people as that becomes required for them. And you click create, and in about 10, 15 seconds, that's going to go off and scaffold your entire backend for you. However, I'm going to click into this MRP backend, and this is going to take me into a single workspace. Now, we have examples of workspaces being used in a wide variety of ways. However, we tend to see that most of these projects start at the data model. Essentially, when I named that 3-tier serverless architecture, Apebase uses Aurora MySQL as the database technology. So it's a relational database in which we've built a graphical user interface that allows you to visually drag and create a data model, which is super cool. Adding tables is as simple as adding tables and giving them a name. Once you give it a name, so for example, let me check out this table here called designs, in which I'm storing design records, right? Now, by default, Apebase is managing 4 fields for you. The ID field, which is a unique or global unique ID, the create at and update at timestamp, as well as a created by relationship, which is essentially saying if this record was created by a user that was authenticated via the API or via the console, doesn't matter, it will store a record that relates it to that user. Right, and if you want to, you can utilize that in some of the other things that we're going to look at during this this walkthrough. Now, adding fields, just as simple. Give your field a name, select a field type, for example, a date type, and then choose some of your configurations on that. Click Create Field, and that field's going to be added to your database. What's really cool about this is it's actually handling the database administration work behind the scenes on your behalf. So it's really performing the call it responsibilities of a database admin, as opposed to kind of just taking this and putting it in a spreadsheet somewhere that's probably not that secure or scalable. This is a real enterprise solution, and that's what we built it for. However, when you look at a built-out table, you can see that you can add a number of different fields, of which there's different field types. the simple ones you're expecting, such as text, numbers, date fields, to more complex ones, such as like file storage, adding file fields, switch fields, which are different types of Boolean fields, as well as even GeoJSON, which is super cool. You're essentially able to store lat-long coordinates in the database and then do queries that say, show me all the records with a coordinate, between or within these bounds that's 30 miles away from me or less, so on and so forth. So a lot of that kind of complex map functionality or calculations are pre-enabled for you when using the 8base API. Now, building relationships is extremely straightforward as well. So for example, let's say I wanted to build a new relationship between my designs table and my users table. I could take my users table, drag and drop it over an empty field, and then here define that type of relationship. Is it a many-to-many relationship, a one-to-many in either direction? Belongs to if there's a mandatory constraint. Essentially, any type of relationship that I'm used to setting up in a relational database, I can configure here. And we've seen examples of people using this tool for as easy as, or for as little as one table that they're just shoving records into, maybe using some type of crawler. Or we have examples of really complex business applications that have over 400 tables in their database. And really the solution is able to accommodate any of those use cases through a simplified interface, but to accommodate advanced or complex use cases, which is super cool. Now, once you go through and build your data model, which as you can see can happen quite quickly, and here I have a number of tables, we give you a nice little data viewer, right? So if I go to my data tab, here I can actually see some of my records, filter through fields, sort through fields, define which ones I want to see within the viewer and whatnot. And this is a really easy way of looking through your data. If I wanted to add a new record, I could go ahead and do that. If I wanted to update an existing one, I could go ahead and do that, right? So a lot of different options in there. However, actually, before I jump to the next piece, some other operations that are important to mention about the data viewer. You have the ability of creating database views, which are really cool. So this is essentially my ability to create a read-only table in my data model that aggregates data from multiple tables. And I'm able to do that by writing the SQL create view statement. So a lot of flexibility in that, as well as if I want to create custom indexes on my tables for more optimized lookups, I'm able to do that as well and create compound indexes by using multiple fields. Now, what's really profound about 8base is that as we're going through this exercise and creating this data model that represents our business domain, 8base behind the scenes is auto-generating the API that we need for all the essentially CRUD and some operations to interact with that data. Now, every workspace that you create has an API endpoint, which you can get right here, as well as the subscriptions endpoint, which I will talk more about in just a minute. Now, if I go to my API Explorer here, we can start to look at that API. So in real time, as we're creating tables, adding fields, this is auto updating. So what I'm going to do here is I'm just going to say, let's look at let's say I want to get a list of designs out of my system. All right. So I'm going to say, let's write a query and I want to see designs list. And very simply, I'm just going to say, I want to know how many I have. And for every one that I have, I want the ID, I want the name, I want the description, I want the number, and I want to know when it was created at and updated at. I run that query. And what's really nice is only the information I asked for in this query is the information coming out of the system, as well as due to the GraphQL specification, this same query that I wrote here is the exact same query that I'd be writing in my front-end application, which is a really, really nice developer interface for your front-end developers, because they get to essentially write their own data requirement, right, and get that response returned to the front end, rather than hit like a REST endpoint, which has a predefined response and potentially have to hit, one or more to get the full data requirement for whichever view they're building. Now, on top of that, what's cool is inside these operations, we've already done the work of creating all the advanced operations. So things like pagination, sorting, filtering, search, even grouping and aggregation. It's all just part of the API. So you can just go in and start utilizing these things rather than figure out how you're going to implement them or build them yourself, which is a really big value add. On honestly, from my own experience, coming from a Django and a Ruby on Rails background, I've seen 8-base cut months off projects that you just be building APIs because we've already done this work that just takes the data model and produces that API for you, which is really valuable. Additionally, all of these queries are fully relational based on your data model, meaning that here I'm querying the designs table, right? However, there's a relationship between designs and I believe variations. Variations is another table. Now, for every variation, let's say I want the description and I want the ID. And variations also have relationships to other tables, such as media, let's say, right? And so I can go into the media table now, and for every one of those, say I want the ID, I want the download URL, and I want the updated at timestamp. So here I'm doing a 3-tier nested query through these different relationships. And when I run it, it goes through all those and gives me that in one response. Once again, just kind of alluding to how nice of an API querying experience this is and how clear semantically it is as well. No having to understand how to do complex SQL joins or any of that stuff. That's what's all being managed for you. Now, one really great thing about the GraphQL specification is that it's a self-documenting specification. So here, we're doing a read query, right? Where we're reading a list of all our designs. If we knew the ID or any unique or mandatory field of a certain record, we could just look up a single design and let's say by ID and get that single record, right? However, let's say that we wanted to know, well, what are our options of actually creating records in the database? Well, here I can go to my Documentation Explorer, click on Mutation, and here let's just say, actually, let's look at variation since that's a different table. So we want to create a new variation. And the variation, and here is showing me all the operations I have available by default for making database writes. So I can create records, I can create many at one time, I can delete or destroy them. That's a soft delete versus a hard delete, permanent versus potentially temporary. Delete or destroy by filter, so perform that operation on a set of records rather than just one record. Restoring records that were soft deleted, updating records, as well as updating records by filter. And the update record by filter one is actually pretty cool because it uses atomic operations. So for example, let's say here that we had this design number and every record we have has a different number. If we wanted to perform an update that incremented that number by 10, we could do that. And every one of those records would be updated incrementally rather than a set value for all of them. So there's a lot of different ways that you can play with that API to do really efficient or performant queries on a batch of records, which is really fun and cool to look at once you get into it. Now, when it comes to all the CRUD operations, so create, read, update, and delete, this API covers it for you in a number of different flavors, right? There's a lot of different flexibility, even for creating multiple records and multiple tables through one query based on the relationships. It's all there. However, what is also there, which is really valuable, are subscriptions. And what subscriptions essentially are is a WebSocket connection over AWS Lambda for real-time data. Now, that allows you in a client application to create a subscription connection to the, or initialize a subscription connection, which then listens to any write operation on the database for the table that you specify and even a subset of records in that table. So what does that enable you to do? For example, we use it for things like building messaging applications, building real-time notification feeds. We're doing a stock ticker type app that needs real-time price updates on the client side. Subscriptions enable all that functionality, and they do it really, really well. So with all the create, read, and update, update and delete operations plus subscriptions, there's a super robust API that comes right out the door for you as soon as you set up your data model. And like I said, that can shave months off an application project, as well as just a lot of maintenance over time, since this is continually being maintained, updated, enhanced. It's a really big productivity tool. Now, once we get to this piece where we can configure a data model using that data model UI or data builder UI, we then immediately get this really robust API that we get to use for our application development. The question then gets asked, okay, well, how do we make sure that only the right actors are being able to interface with our API, right? So what's the concept of roles and permissions within this tool? Well, if we go to application services here, or app services, we have a view called roles. And we decided to build this natively into the console because it was such an important part of application security that we wanted to make sure our users had a solution for. So what I'm going to do is I'm going to go in and just create a new role. And let's say that for this MRP backend, which is a manufacturing type backend, let's say that there's a role here called floor manager, a person who manages the floor. I'm going to add that role, which is really just a placeholder name. However, now when it's created and I click into it, what's really cool is 8base is now giving me a view into where for every type of action I can take at the data level, so creating records, reading them, updating them, deleting them, even field level access, I can go and permission it for each table. So let's just go down here and look at let's find the design one. So as a floor manager, I'm not a designer. I'm not going to be creating designs in my system. So I'm going to unclick create. And now any user that only would have the floor manager or not any other role that would grant them that permission would not be able to execute queries to the API when they're using the application that created a design, no matter what our front-end developer writes. So this makes sure that the security is handled server side rather than relying on our application developer or front-end developers to enforce those permissions. When it comes to reading records, we'll absolutely say that they can read all those records. And when it comes to updating them, let's just say that for now, they can't update any records and they can't delete any design records. Now, for example, let's say that for some reason we allowed them to update records, let's just say all records. If we wanted to, we could then drop into field level access and say only which fields they were allowed to update. So maybe we want them to update with the record. However, we want all fields to be read only, except for the drive URL. Maybe for some reason they're updating that URL value through the interface. And so we can make sure that only that is actually editable by that user role. Now that's super useful, right? However, all we're looking at is very binary type choices, right? So all records, no records, users records, right? So for example, let's say here that a floor manager, they're constantly creating pieces on the floor, so they can create pieces, they can read them all. However, they can only update the ones that they were creating, right? However, so what does that mean, users records? Well, under the hood, what's really happening is a filter is being applied. So in this regard, it's saying, okay, well, was the piece, that record, created by a user whose ID equals the logged in user ID? And this ID would come through the bearer token, or there's different ways of us collecting essentially, but API or console works either way. Now, these custom filters give us tremendous flexibility in the types of permissions and essentially the ways we can scope and organize our database and our roles in security. Because this right here is just looking through one relationship, which is, does the piece belong to, was it created by a user? However, let's say, just for the sake of example, let's say, does the piece belong to a variation where some design, so what else do we have here? The design number contains the string 10, right? So we could see here that we could do or we could do different levels of nesting. Essentially what we do here at 8base when we're building multi-tenant SaaS solutions for our customers is we have these roles reflect the data model to see whether or not certain users belong to certain companies, and companies as a table in the database. Regardless to say, there's a ton of flexibility that you can implement here, and it works really, really well. This is just a fun example of showing that we can go through 3 different relationships to check a value on a certain record, and that actually be the permission or the permissionable check that we're going for there. So I'm just X out of that. Now, what's also important to note about roles is they not only work for your application users, but they can also work for your developers. So for example, let's say that I was going to have a developer collaborate on this project. However, I did not want them to be able to change my schema, right? Or I didn't want them to be able to see certain records in my database. I'm just going to update this user role to be called developer one role. So what I can do is, first thing is that any permissions I set in here will also be enforced via the console. So if they went to that data viewer and I said that you can't read any record in the design table, then no records would show up there, right? So that's a nice tool in itself. And then if I go over here to this app section, I can essentially toggle what they are or aren't allowed to do. So can they manage schema or can't them? Can they look at the viewer or can't they? So on and so forth. So you can use this both for your developer permissioning as well as your application user permissioning. Now, when it comes to authentication, which is just the next section here, 8base is not an authentication provider. So we do not store passwords, right? We encourage you to work with any authentication provider that's OpenID compliant, which is most any reputable one. So we encourage you to work with Okta, Cognito, Auth0, Google Identity, Microsoft Identity Server, any of them that are out there really, you can plug in. So essentially how that works is you create an authentication profile, you give us the provider URL, and then when you authenticate with that authentication provider, and you use that ID token that they issue you as a bearer token in your 8base API requests, that we decode that, we then go check it with the provider. And if that is a valid token, we know that it's valid authentication. And we're able to map that back to the user record in 8base. Now, essentially, there's a table for roles in 8base and there's a table for users. And there's a many-to-many relationship between the two. So a user can have many roles. And by verifying that ID token and then getting the payload out of it, finding the identified credential, we're able to map that user record and see all the roles, and that's essentially what drives that engine there. However, once setting up this authentication profile, we give you some customization of saying, okay, well, even if you're authenticating with your authentication provider, are you going to allow people to sign up for this app, self-sign up for the 8base application essentially? Or is it only for certain email domains? Is it open to everyone? You want to assign some roles by default? Just some little extra flexibility there for you. However, once you create that resource, then you have the different client ID information or client information that you use to initialize authentication on the client side. We have a bunch of tutorials online and documentation that talks more about how to do this. However, this is just some of the information here that, that you get to utilize when building your front-end application. Now, one important thing to mention here is that it might seem like, oh well, the only way of giving someone a certain role is selecting it at the authentication profile, which then you would ask like, well, what if I want someone to have a role after they've authenticated or after they've signed up for the first time? What's really cool about 8base, or at least to me, what I think is one of the defining parts of our system, is that the entire backend itself is an API. This console that we're in right now, it's just 8base's version of the front of the administrative console to really what the value is, which is the 8base API. Now, what does that mean? That means that, let's say I wanted to go to my API, write a mutation that goes into my backend and creates a new table in my data model. I could do that programmatically. So this means that if I wanted to, and if I loved the 8base API, but I didn't like the 8base console for some reason, I could go build my own console. If I wanted to make the generation of any server-side resource a part of a user flow, I could handle all those programmatically. So there's a ton of flexibility in the different ways that you can enable your application functionality using the API without being restricted to having to approach or log into the console to accomplish that, which is super cool in my opinion. Now, I'm going to jump down to settings and just look at two quick things before we jump into the final part of this demonstration, which is first off, API tokens. So the authentication tokens I've been talking about were ID tokens issued by your authentication provider. which really represent like a session, right? That's a single user and it's identified by that user. And now we also have the ability of creating API tokens and assigning roles to them. So this issues you a static token, never expires, and you can define the roles and permissions for that token. So for example, whether that's to authenticate different IoT devices, right, which you don't necessarily give them a username and password because they're not actively logging in, but they need a credential, works great for that. As well as if you want to enable server-to-server communication, right? So let's say that you wanted to have functions, which we're gonna look at in a minute, deploy automatically from GitHub when they're merged into your master branch. You could do that by setting up an action script and creating an API token that gives the GitHub that permission, right? So that is there. And then finally, environment variables, which if you have sensitive keys that you need to use in your serverless functions, you can store them here safely and not have to commit them with your code. So let's actually jump now into what the serverless functions look like. Let me just pull this up really quickly here. Don't save. Let me switch my screen 1 second. Okay, cool. So here I am now in VS Code. So in 8base, the console experience that we kind of just walked through, we usually see handling 80% of the project, right? Or the backend project, excuse me. But that's the 80% of the project that could be generalized and abstracted into a platform. Now, almost all projects that we get involved in require server-side customization, right? Different workflows, different types of complex validations. These are all things that we didn't want people to be limited when it came to, because these are usually the unique parts of the application that need to be enabled for it to be a real service. So what we decided to do was just give people the full power of JavaScript, right? Or so TypeScript, JavaScript, serverless functions. And we did that by first building a command line tool to help manage that process, and then building these types of functions, which we can walk through now. So using any JavaScript package manager, whether that's Yarn or NPM, you can quickly install the 8base command line tool, 8base CLI. And that makes, I will recommend installing it as a global across your machine. And then that gives you the capability of logging into the command line, initializing new projects, doing migrations, generating functions, all these different things. However, here, to get this just default directory that I have created, all I did was run 8base init. I gave it a project name, and then I said that I wanted my syntax to be JavaScript. It defaults to TypeScript. That's just, but you can say JavaScript or TypeScript, and the function generators will work accordingly. Now, when you initialize a project, it's a pretty simple package, workspace.json file, which essentially stores what environment are you working in 8base, the workspace ID, and then the API, as well as the package.json file. This is an NPM package, and we'll talk more about that in a second. And then the core file, which is the 8base.yaml file. Now, 8base gives you 4 function types that you get to utilize. So the first kind is a resolver function, which is a way of extending your GraphQL API. The same way that we had a design list operation or a create or a variations create operation on our API, which reflected our data model, you can write custom resolvers, which take any input and return any output and execute any code in between them. So the ability to very quickly and very streamlined author completely custom GraphQL operations for your backend or for your API. Task functions, which allow you to encapsulate code and invoke it from other functions. Or if you want to, you can run tasks on a schedule, which is essentially cron syntax, right? So any type of cron job, you can give it that, and that will be the cadence on which that function invokes. Or you can give it a very simplified syntax, such as at a rate of every 5 days, and it will execute on that. So cron can be a little bit intimidating sometimes, so we give both options. Webhook functions. Webhooks are essentially your ability to stand up traditional HTTP endpoints on your API, which can receive callbacks from third-party systems. So for example, let's say that you wanted to build a Zapier integration to your 8base backend. You could absolutely do that by putting up the appropriate webhooks. Or let's say that you just you were using Stripe as your merchant payment gateway. And then every time there was a transaction in Stripe, you wanted a callback to happen to 8-base, get that payload and digest it somehow. You could do that very easily by standing up a webhook function that executes that function to handle that. And then finally, triggers. Triggers allow you to invoke a function either before or after there's a create, update, or delete operation occurring on any table that you specify. So before triggers are really great ways of doing complex validations, right? So if you wanted to make an API call to check a third-party system before a record is created or updated, you could absolutely do that. You could then coerce or manipulate the input, or you could reject the operation altogether by throwing in a custom error and returning that error via the API. And then finally, too, after triggers are a fantastic way of triggering different workflows. So these projects are NPM packages, right? Or they use NPM. So you can install any NPM package or any package from the JavaScript ecosystem, whether that's an SDK, a library, whatever you're using, and utilize it in those functions. So in an after trigger, let's say that you wanted to import the Twilio SDK, and after importing that, after a update event happens, a delete or a create event, doesn't really matter. You initialize your Twilio SDK, you send an SMS to someone or an email to someone. You can do all that stuff programmatically, and 8-base is completely giving you a great environment to do it within. Now, 1 second, there was a quick question being asked. Can you set up webhooks with Salesforce integration? Absolutely. So there is 2 things. We have a native Salesforce integration, which essentially allows you to proxy your Salesforce via the GraphQL API. So you set up that integration, and then the same GraphQL API we were just looking at, you can query your Salesforce account, which is a really cool way of doing it. However, if you just wanted to work directly with Salesforce and set up some webhooks on the 8-base side that Salesforce sends webhooks or callbacks back to, you can absolutely do that as well. So 1 second, let me see what to do. Cool, I'm gonna close that there. All right, so let's just look at a quick trigger function really quickly to demonstrate these functions. They are very straightforward JavaScript functions. So event.data, and there's a few different, depending on the trigger type, there's different ways of getting the event data that's invoking this function. We'll give you the usable data in the function and any other headers or arguments being passed to the function. Also, the context argument that we have here is where we actually give you an instance of your own API, as well as the ability to call those task functions. So for example, if I wanted to invoke, and if I wanted to call one of my task functions here, I could call it by name, task 1, and then I could pass it any data that I'm passing it in there. And of course, I could await the response, or I could not await the response, whether I wanted that be a synchronous call or an asynchronous call. Also, on the context argument, we give you your own API. So context API.gql request. And inside here, I can author any mutation or query, execute that, wait the responses, handle anything programmatically. So a lot of flexibility there. Now, like I said, you can install any SDK, any JavaScript library, and then import it into these functions. So in that example of Twilio, if I wanted to import Twilio from Twilio, and then await a Twilio API call that, let's just say, sends SMS. I'm just gonna fake it right there. So imagine that all the proper arguments were being passed. You could do that as well. So a ton of flexibility. And also too, these directories are working directories, right? So let's say that I was sending text messages in all my functions, and I didn't want to have to get my API key, initialize it every single time, and do all that in every function. I could create, let's say, a utils directory in which I initiate my Twilio SDK once, and then I can import it relatively into my function, and that would work in production just as expected as it does in development. 8-base handles the compilation of your projects and make sure that all that's respected. So it works in both capacities. Now, if I wanted to test any of these functions, there's some cool options. So first off is every function that you create has a mocks directory. And this is essentially a stub object for the event argument. So I can create any type of stub object that I want, or any type of mock that I want to test different arguments being passed to my function, in which case I then use this command, base invoke local, the name of the function, and then the name of the mock file, and that works accordingly. Yeah, and you just test that locally, see that it's working. And then finally, once everything is, you have the ability to deploy that. Now, deployment is as easy as running an base deploy, and that's going to deploy your functions up, and they'll be live in a minute or two. However, we tend to see that for production applications, they tend to have set up our CI/CD, which essentially allows you to have a siloed environment for each, or multiple environments for each workspace. So for example, in the workspace we were just looking at, that was the master environment. However, I could branch off that staging, development, different feature branches, all that I want to, and then have that be my implied CI/CD deployment pipeline. So then when I make changes, I'm making those changes in the youngest child branch, in that 3-tier one, let's say it was development. I'm testing that all those work, that environment has its own API. And then once they all do, I generate a migration script I generate a migration using the base command line tool. And then I can migrate that to development, or excuse me, to staging. Once all the checks pass there, I can migrate it to production. And so you're really making sure that everything is being deployed safely before it hits your users. Now, you don't have to use that, right? It's more of an advanced feature, but we do find it to allow people to more consistently to deploy stable software to their end users. So that is really all I wanted to cover today. I'm going to open up the QA really quickly.